Hello everyone, you're with Mr. Laurie, and this is part 9 of the linear and nonlinear relationships topic. In this lesson we're going to be looking at cubics. So what exactly are cubics? Well, we've looked at parabolas, which were graphs where the highest power in the equation was 2. So what happens if we increase that power to 3? So instead of y equals x squared, we have y equals x cubed. Well, like always, to get a basic idea of what this graph looks like, let's draw up a table of values and then we'll plot the points. As you can see, this table of values looks a little bit different to ones we've used previously. In this one, we've got a little bit of extra detail just because of the nature of the graph. Okay, so that's why there's some 0.5s and negative 1.5s, etc. Let's start off with the whole numbers though. We'll start with 0. When we substitute x equals 0 in here, 0 cubed is just 0. So our first one we can put there, and then let's move over to 1. When x equals 1, 1 cubed is just 1. It's a nice easy start. What about when x equals 2? 2 cubed, 2 times 2 times 2, that gives us 8. So you can see we've got a big jump now in our y values. Moving over to our negative x values, we get a similar thing, although when we cube a negative, right, that's a negative times a negative times a negative, our final answer is negative. So we get negative 1 and negative 8. Just going quickly through the 0.5s. 0.5 cubed gives us 0.125, and 1.5 cubed gives us 3.375. And likewise, we get the negative versions of those numbers for the negative x values. 3.375 negative. Okay, so that's why we had some bigger squares there in our table of values, so we could fit those in. Okay, with this data, let's plot the values and see what our curve looks like. Let's start with 0, 0, right at the origin. And then moving either side of 0, 0, we've got 1, 1, and negative 1, negative 1. In between those, we have a half and 0.125, so it's going to be very close to the x-axis, and the same over here, but just below. And then when we go to 1.5, we go to 3.375. So 1.5 to 3.3 around here, and the same over in quadrant 3 around here. And then 2 jumps all the way up to 8, and negative 2 goes all the way down to negative 8. We can see that if we kept going, if we substituted in x equals 3, we would get 27, and likewise negative 27 when x is negative 3. So let's join these points now with a smooth curve, smooth as possible, to form a cubic. Put some arrows on the end. So that is our basic cubic function. Now that we've drawn our graph, let's briefly discuss some features that we notice. The first thing is that as we move from left to right, the graph always increases. It always rises, and what we call this is an increasing curve. So it is an increasing curve. So as we move from left to right, at no point does it turn around and go back down like a parabola might. It always increases. The second thing is to notice that the graph exists when x is positive and y is positive, so quadrant 1, and then when x is negative, y is negative. So let's note those two things down. When x is positive, y is positive, and vice versa when x is negative, because when we cube a negative, we get a negative. Other important features of graphs are the x and y intercept, and we can see that the x-intercept and the y-intercept both equal 0. Finally, not only is it an increasing curve, but as x increases, y increases very quickly. We can see that this graph gets larger a lot quicker than a parabola. So the y values get big really quickly as x increases. Okay, so there's some key features of our cubic graph. We're now going to have a look at Desmos and see how the graph changes as we manipulate some of the variables. Beginning with our standard cube, y equals x cubed. Let's see what happens if we vary the coefficient at the front. So instead of 1x cubed, let's change it to 5x cubed. Alright, so like we should expect from other graphs, when we change that coefficient out the front, we get a much steeper, narrower graph. Okay, it's still passing through 0, 0, but much steeper. And if we change our coefficient to something less than 1, say 0.2 x cubed, we get a flatter, wider cubic graph. Okay, this purple one here, that's still going through 0, 0. What about if we add something onto our graph? So we might start with y equals x cubed, but then we add a constant term. What do you think will happen? Well, based off what we've seen, if we add a constant term, it pushes our graph up. It translates it up by 1 in this case. So instead of going through 0, 0, it now goes through 0, 1. So exact same curve, but just moved up. Or we could move it down, say 1.5 spots, or just down 1 spot, or maybe down 2 spots. Okay. So that constant at the end there just translates our graph up and down, while the coefficient at the front makes our graph steeper or flatter. Okay, now that we've had a little look on Desmos at what happens to our graphs, let's go and write a few notes to finish off. When we changed the coefficient out the front, let's call it A, we either stretched or flattened our curve. So it narrowed or got steeper for A greater than 1, or it flattened or got wider for when we chose a value that was between 0 and 1. And when we added some constant term on the end, okay, that just moved our graph up or down. And so moved up or down by d places in this case, whatever number this constant term d is. One thing we haven't looked at, so we might jump back to Desmos just quickly. What if this a term is actually a negative? So what if we have y equals negative ax cubed? What's going to happen then? So before we have a look on Desmos, have a think what will happen if we take every y value that we previously had and suddenly made it the negative version. So here we are with y equals x cubed, and instead of positive x cubed, let's put our negative in. Alright, we get a flip about the y-axis, or about the x-axis. Okay, either way, it's been completely mirrored. Okay, all the y values that were previously positive are now negative, and all the y values that were previously negative are now positive. So there's been a flip of the graph. So our positive cubics will go upwards or be increasing from left to right, and our negative cubics will be decreasing curves. They'll go down from left to right. So just summarizing, if we make our cubic negative, it's been reflected in the x-axis, and we could say that it is a decreasing curve, okay, as opposed to our standard cubic, which is an increasing curve. So that wraps up cubics. A bit of a shorter lesson today. Hope you've enjoyed, and all the best doing the questions.